Hello, we are looking at lesson 8.3, which is all about special right triangles. Now, I'm going to show you a little trick so that you can take your notes and watch this video at the same time. So what you want to do is you want to take your OneNote and go to the very top and make sure you slide this OneNote all the way to the end, and it's going to split your screen. And what you could do is then you can select your browser which has this video. So you could have your video playing over here as you're taking notes over here. Now you might need to adjust your screen a little bit over here so that you can have more space. So you might want to go ahead and pull this off to the side and this one as well, and then zoom in, zoom out as needed in order for you to take your notes. Okay? So now that I've just shown you how to split your screen so that you can watch the video and take notes at the same time, what you're going to do is you're going to go ahead and work on the two warm-up problems that are in your 8.3 notes. So pause the video now, and then once you're done, you're going to check your work with me. Alright, ladies, go ahead and check your work. Make sure you've shown all your steps, especially for number 1. Make sure you have checked to see first, is it a triangle? And then you're going to classify. So in case you need some more reference, you can always go back to lesson 8.2. This is what we learned in that lesson. So you can always go back to that lesson to help you out. We're going to go ahead and move on to today's lesson, which is all about special triangles. So we're going to learn two triangle theorems, and the first one is called the 30, 60, 90 triangle. So if you look at this triangle right here, you'll notice that it's a right triangle. We have a 90 degrees, and this is special because the measurements that we have are 30, 60, and 90. So whenever you have a triangle like this, the sides have a special property that allows you to find the missing sides a lot more faster. So the side that's opposite the 30 is always going to be S. The side that's the hypotenuse is always going to be 2 times of whatever S was. So remember, we have our hypotenuse, which is always opposite the 90 degrees. And then we have the side that's opposite 60 degrees. That's going to be always whatever S is times the square root of 3. So this is a special property of this special triangle in which you have 30, 60, and 90 degree angles. Let's go ahead and see this as an example. So realize over here in this example we have the 90 degrees and then we have the 60 degrees, which automatically makes this angle 30 degrees. So we have a 30, 60, 90 triangle. And realize that the side that's opposite the 30 degree angle is called S. So I'm going to call S, which is equal to 3. Now, if I want to find the side that's opposite the 60 degrees, then what I'm going to do is it's just going to be S times root 3. So whatever S is, I'm just going to multiply that by root 3. Well, S was 3. So X is going to be 3 root 3. And that's it. I didn't have to use the Pythagorean theorem. I didn't have to do anything. I just have to look at the special relationships that it has and substitute the values that are known to find the unknown. Last bit is your 90 degree angle. And so the side that's opposite the 90 degree angle is always going to be 2 times whatever S is. So in this case, S is 3 because that's what we said over here. So 2 times 3 is just going to be 6. So X is 3 root 3 and Y is 6. And that's it. It took us about a minute to solve this problem. The better you get with these, the quicker you're going to solve them. Okay? Let's go ahead and move on to this. I'm going to do one more example with you, just to show you how this looks, if it's turned around a little bit. But the idea is the same. So realize that the side that's opposite 30 is going to be called S. So this is S right here. And because this is S, the side that's opposite 60 is going to be S root 3. So now comparing these two, realize that if this side right here is S root 3, and it's also equal to 11 root 3, well, what do you think S is going to be? S is going to be just 11. Just like that. And so, remember the side that's opposite 90 degrees? That's going to be 2 times of whatever S is. And since S turned out to be 11, Y is going to be just 2 times 11, which is 22. Just like that. Again, took us about a minute to help to figure out the missing side. All right. This next triangle over here, again, we can see it's a 30, 60, 90. Realize that the side that's opposite 30 here is something that looks a little scary. But this is going to be what our S is. So let's go ahead and just set this equal to S. And if we were to find Y, remember Y is just going to be 2 times S. So if S turned out to be this big looking thing, 4 root 3 over 3, then Y is just going to be 2 times that. And so we just go ahead and simplify. Y is simply going to be 8 root 3 over 3. Done. Just like that. Now, to find X, X is the side that's opposite the 60 degree. Now, if I want to find X, what we're going to do is we're going to go ahead and set it equal to the side that's opposite 60 degrees looks like this. We have S root 3. Well, since S is 4 root 3 over 3, I'm just going to multiply that to root 3 over 1 maybe, to get what my X is. So multiplying throughout, we're going to get 4 times 3 over 3. We can go ahead and simplify this out to just 4. So X is going to be 4. There we go. Took us about a minute to solve this problem. All right. What I want you guys to do is use the Pythagorean theorem. Let's go ahead and write that down, Pythagorean theorem, to find the length of the diagonals for each of those squares. And let's see if we can notice a pattern. So use the Pythagorean theorem. You're looking for X, which is the length of the diagonal in each square. Pause the video now. All right, so realize for the first diagonal, you should have gotten 7 root 2 if you simplified your radical. And for the second diagonal, you should have gotten 8 root 2. Now, this is not a coincidence because the number that you had on the side, that's the same number that you see in your final answer, and we've added the square root of 2 onto it. Now, what this is another special triangle that we're looking at. So remember, a square has a 90-degree angle, and the diagonal is bisecting the other 2 angles that we have. So this is going to turn out to be 45 degrees, and this is also going to turn out to 45 degrees. So here, the type of triangle that we're looking at is called a 45-45-90 triangle. And that's the other theorem that we're going to learn about. So, if you have a 45-45-90 degree triangle, then this is how it works. The side that's opposite 45 degrees is called L for legs. And the side that's opposite the 90 degrees is going to be whatever L is times the square root of 2. Remember, in the square that we had over here, we had the legs be 8, and the diagonal, which was opposite the 90 degree, ended up being 8 root 2. So that's another special property, and this property is true when you have a 45-45-90 triangle. So looking at an example, notice that we have a 45 degree here, a 90 degree here. So this is also going to end up being 45 degrees. If you add up all those angles in that triangle, it should equal 180. And because we have an isosceles triangle, we can say that these two sides are going to be congruent. So this is also 9. And because this is 9, we can say that this is just L. And the side that's opposite 90 degrees is going to be L root 2. And since L is 9, X is simply going to be 9 root 2. Done. Makes it a lot more easier for us to solve those problems. Let's go ahead and look at a couple more examples. So looking at this, realize that we have two sides that are equal to each other, which means we are looking at an isosceles right triangle. And because this is an isosceles triangle and we have a 90 degrees, this automatically means that these two angles are going to be congruent, which makes them both 45 degrees. And so we have a 45, 45, 90 triangle over here. So remember that the side that's opposite the 45 degrees is called L. So I'm going to go ahead and name this L. And the side that's opposite the 90 degrees is L times the square root of 2. And since L is 6 root 2, let's go ahead and substitute. Well, in order to find X, I just multiply it by root 2 again, because that's what X is going to be, L times root 2. And so finally, I get 6 times 2, which is going to be 12. So X is going to be 12, just like that. All right. So what I want you guys to do, or you know what, let's go ahead and go through this problem together because it's a little bit different. So realize we have a 45, 45, 90 triangle again. And in this case, we're given the side that's opposite 90 degrees. So remember that the side that's opposite 90 degrees is going to be L root 2. So on the side, we're going to go ahead and write down this equation. L root 2 is going to be equal to 8. And remember that the side opposite 45 degrees is going to be L. So sides opposite 45 degrees is just going to be L. Now, because I have this equation, I can get L alone. I can solve for L. And all I'm supposed to do is divide by the square root of 2 to get L alone. And that's what I'm going to do over here. So if I do that, L turns out to be 8 square root of 2. But we cannot have the square root of 2 on the bottom. So we got to multiply both the top and the bottom by the square root of 2. This is called rationalizing the denominator. Let's go ahead and write that down. Rationalize the denominator. And we're going to simplify. So simplifying this gives us that L is equal to 8 root 2 over 2, which is simply 4 root 2. And so going back here, since L turned out to be 4 root 2, A is going to be 4 root 2 on both sides. And it's going to be the same thing on both sides because it's an isosceles right triangle. So that's how this one worked out. So if you have an equation, you can always use that equation to solve for the unknown. In this case, our unknown was L. And that's how you would do it with a 45, 45, 90 triangle. By the way, you could have also used Pythagorean theorem on this, and if you had done a squared plus a squared equals 8 squared, you would have gotten that a equals 4 root 2. So either way works. Sometimes the Pythagorean theorem might seem easier, and sometimes knowing the special property might be easier. Okay? All right. So what I want you guys to do is practice now. Some of these are 45, 45, 90 triangles, and some of these are 30, 60, 90 triangles. In either case, you want to label your triangles properly, and you want to find the missing side length. So you want to find out all of those that have a question mark on there. Show your work, and then check your answers with me. Pause the video now. All right, ladies, go ahead and check your work. See that you understand it. If you have questions, you can ask the person in the room, or you can see Miss Lloyd during one of her off periods and ask her questions as well. You could also ask me questions when you see me in class. we're going to go ahead and move on. So let's go ahead and look at the next ones that we have. So again, over here for G, I have an isosceles right triangle, which means this is going to be 5 root 2, and I'm looking at a 45, 45, 90 triangle. So I'm going to use my properties of 45, 45, 90. So realize that the side that's opposite 45 degrees is going to be L. And so my hypotenuse is going to be L root 2, which is going to be basically whatever L is. So 5 root 2 times root 2. So we have L, and then we have the root 2. And so when you simplify, you just get 5 times 2, which is 10. So the missing side is going to be 10. All right. Over here, we have a 30, 60, 90. Remember that the side opposite 30 degrees is S. The side, I'm going to go ahead and write it as a cursive S because I don't want to get it confused with 5. So side opposite 30 is S. Side opposite 90 degrees is 2 times S. So if 2 times S is 10, obviously S has to be 5 because 2 times 5 gives me 10. And so to find this other missing side, right over here with the 60 degrees, the side that's opposite that one is going to be S root 3, which is just basically going to be 5 root 3. And we're done. So we found our 2 missing sides, just like that. Okay, here we go. Let's go ahead and move on. So over here we have an equilateral triangle. So let's go ahead and draw a triangle that looks like it's equilateral, which means all 3 sides are the same. So even if it doesn't look equilateral, we could always use our markings. And now it is an equilateral triangle. Well, if the perimeter of that triangle is 45 inches, then what we want to do is we want to find the length of each side. So 45 divided by 3 is going to give me 15, which means each side is going to be 15 inches. And what we want to do is we want to find the length of the altitude. So the altitude goes from the vertex and it makes a 90 degrees, just like that, on the opposite side. And because this is an equilateral triangle, what it does is it divides that side into 2 equal parts. So originally this entire side was 15. Now that it's broken in half, we're going to have each part being 7.5. And remember, when you have an equilateral triangle, all the angles are going to be 60 degrees. Equilateral triangle is also equiangular. It's a regular polygon. So now that I have the altitude going down like that, realize that this angle got broken in half. I'm going to have a 30 degrees over here. And so what I'm looking at is a 30, 60, 90 triangle. I'm going to go ahead and draw it out separately so you guys can see the bigger picture, or the smaller one in this case, with this being 60 degrees, this being 90, and this one being 30. So realize that the side opposite this 30 degrees is 7.5. The hypotenuse is 15, and it makes sense because remember the side opposite, if it's S, then the hypotenuse is 2 times S. So if I want to find out what the altitude is, well, that's just going to be S root 3. And so final answer, we're going to write down altitude is simply going to be whatever S is, so S is 7.5 times root 3. Now, because this is a decimal already, what we're going to do is we're just going to have our final answer be a decimal, and we're going to round to the nearest whole number. So you'll notice that when you type this in your calculator, you're going to get 12.99, which is the same thing as 13. So I'm going to say that the altitude is 13 inches. And we're done. All right. Let's go ahead and look at number 1 over here. We have a rectangle. Let's go ahead and draw out our rectangle. And it says that the diagonal of this rectangle forms a 30 degrees with its base. And that diagonal is 24 centimeters long. So here's my diagonal. It's 24 centimeters long. And it's making 30 degrees with the base. Remember, a rectangle has a 90 degrees already in its corner. So you're looking at a 30, 60, 90 degree triangle. And so what you want to do is you want to find the perimeter and the area of the rectangle. So it would help to know the missing sides over here. Go ahead and find the missing sides and use those missing sides to find the perimeter, which is adding up all the sides, and then the area, which is going to be the length times the width. Pause the video now. All right, ladies, go ahead and check your work. For number 2, go ahead and draw the picture of an equilateral triangle. This time the altitude is given to us. Use this example that we did over here to help you figure out the relationship between the other sides. And again, you're going to use your special triangle measurements to figure out what the perimeter of this equilateral triangle is. Pause the video now. Alright, go ahead and check your work. You might have gotten your final perimeter as a decimal, and if you did and you round to the nearest tenth, you're going to get 41.6 square centimeters. Okay? Alright, let's go ahead and move on. So over here we have a quilt in this design, and we have a square. So all of these sides are 3 inches each. So that's what the question is telling us. So all of these are 3 inches. So we might want to just go ahead and put in 3 inches just like that. Okay, and this pattern divides the square into 8 isosceles right triangles. So look at this triangle right here. It is an isosceles right triangle. And what we're going to do is we're going to find the dimensions of each triangle, which means we want to find the sides of that triangle. So if I go ahead and just draw it out separately, realize it's going to be an isosceles right triangle, which means these two sides are going to be equal. I'm going to have my 90 degree and I'm going to have my 45 degrees over here. So this is a 45, 45, 90 triangle. And realize that this right here, this length right here, is going to be half of the 3 inches. So I can say that this is 1.5 right here, which means this is also going to be 1.5. So there we go. We have 2 lengths already. We have 2 sides already. And remember, the sides that are opposite the 45 degrees are called L. The side that's opposite 90 degree is L squared root of 2. So if I want to find out the side that's opposite 90, all I got to do is I got to substitute my L, which is going to be 1.5. And if I multiply that to root 2, I get my diagonal. So let's go ahead and do that. We're going to put that in our calculator and round it to the nearest tenth. We're going to get 2.1. And there we go. Those are my dimensions. We have an isosceles triangle whose dimensions are 1.5 inches, 1.5 inches, and 2.1 inches, just like that. And there we have it. This is our lesson for today. 45, 45, 90 triangles and 30, 60, 90. Make sure you remember the properties of them. You want to basically remember this right here. And you want to remember the other slide with the theorem that states the properties. So those are the ones that you have to memorize for your assessment. Okay? Alright, ladies. That is it for this video. I'll see you guys next time. Bye-bye.